So starting with AS basics, okay? So AS, we're going to start. AS, you had your reversible reaction, so we're going to start with that. Reversible reactions were reactions that could go on in both directions, okay? Forward and backward, okay? So one of those reversible reactions was ये आपका कौन सा वाला था? It's like the Haber process. So an example could be that you got N2. So you got N2 and you got H2 and they're reacting Haber process. There's a reversible reaction and they're forming 2NH3. So that's one example of a reversible reaction. Happens in both directions. There's a thing called a dynamic equilibrium, which you are quite aware of. What's a dynamic equilibrium? When the rate of forward and backward reaction is exactly the same. That is what a dynamic equilibrium is in a reversible reaction. So when the rate of forward reaction equals the rate of backward reaction. In a reversible reaction, ठीक है? अच्छा, then you have और ये पता होगा, ठीक है, the rate at which the products are getting formed and the rate at which the reactants are getting formed back again, ठीक है, that rate is equal, ठीक है? So that means when you've reached a dynamic equilibrium, the concentration of the reactants and products, it stops changing. Even though the reaction is going on. Okay, and your products stop changing when you've reached a dynamic equilibrium. A graph for a dynamic equilibrium would kind of look like this. Okay, let's say you've got you're plotting the concentration of the reactants and products. So normally what happens is products बल्कि नीचे होंगे. Normally what's going to happen is that initially you're going to have a lot of reactants, okay? Normally you have a lot of reactants. And then the concentration of those reactants, it starts to decrease. And eventually it will reach a point where it's probably going to become so it's going to reach a point where it's probably going to become constant. Okay, so that's how your reactant concentration would normally change. Okay, so you start off with a lot of reactants. You are going to start off with a lot of N2 and H2. Okay, slowly what will happen is that they're going to get used up and their concentration decreases. But in a reversible reaction, it never goes to zero. Why does it not go to zero? Because at the same time, your product concentration, which is initially, let's say 0, starts to increase. And eventually at a certain point, it would probably become constant as well. Now that does not in any way means that the reaction has stopped. What it only means is that the product concentration has stopped changing. Why? Because the rate of forward reaction has now become equal to the rate of backward reaction. So if any extra products are formed, those products are turned back into reactants. So your net quantity of your products and the net quantity of your reactants, it stops changing. Okay, so when you reach an equilibrium, the reaction is still going on, except that the quantities are not changing at that point. Okay, so this is the point where we can state that equilibrium has been reached. ठीक है, ये सारों को clear है? Is this clear?
Yes.
Okay, so your graph is going to look like the concentrations are never going to be equal. Every reactant and product would have a different concentration. They can be equal, but they can be different as well. Except that once a dynamic equilibrium is reached, the reactant concentration and product concentration, it stays constant. Okay, whatever it is, okay, it stays constant. Sometimes the dynamic equilibrium favors the product. So in that case, you will have a lot of products and you will have very less reactants. Sometimes the dynamic equilibrium would favor the reactants. That means you would have a lot of reactants and you would have very few products, but the reaction would be at equilibrium. Even if you have a few product, the concentration would not change because the rate of forward and the rate of backward are exactly the same. Okay. So that's your dynamic equilibrium. Okay. But related to your dynamic equilibrium, there's a concept called there's a thing called the Chatelier principle. Again, this is O-level stuff. So Chatelier principle kya tha? It's when the rate of it just means that the equilibrium or the dynamic equilibrium would oppose any change that's introduced. So it's going to oppose any change that's introduced to the system. उसका example वही है कि let's say we have a water container. ठीक है, let's assume that the water container is at equilibrium. एक से blue ink है. अच्छा, so let's say that the water container is at equilibrium. There's water liquid. Water liquid is constantly evaporating. ठीक है, and it is forming water vapors. So, and the same water vapors are constantly condensing and they're forming water liquid. Okay, so that means the system is at equilibrium. There are three rules to an equilibrium. One is that if I increase temperature, okay, so naturally, if I increase the temperature of the container, then which reaction is going to be favored? Evaporation is going to be a lot faster. Okay, so the rule number one, whenever you increase temperature, so for example, ये case है, so evaporation is going to be much faster compared to condensation. So whenever you increase temperature, we can state that the endothermic reaction is going to be favored. ठीक है, hopefully ये सारों को पता होगा. ठीक है, this is like very basic. अच्छा, vice versa, if I decrease temperature, in this container, if I decrease temperature, then your evaporation would probably slow down, and relatively speaking, your condensation is going to be a lot faster. Okay, at a lower temperature, there's going to be a lot higher condensation. So यहाँ पे the exothermic reaction is going to be favored. So then you have तो ये पहला rule है. ठीक है, that's rule number one about temperature. ठीक है, make sure you know this, or hopefully you already know this. ठीक है, something very.
Sir,
हाँ जी.
sir, can you repeat that part about condensation?
मतलब वो है ना कि अगर if you increase temperature, right? So what reaction? I mean, there are two reactions going on. Like if you have a water bottle, right? So what you have is you have evaporation happening, but at the same time, the water molecules have no place to go. So at the same time, condensation is happening. Normally it's at equilibrium. Okay, a closed water bottle is at equilibrium. Why? Because the rate of evaporation and the rate of condensation is exactly the same. But if you increase temperature, the evaporation would be faster. Vice versa, if you decrease temperature, then obviously condensation would be a lot faster. The water vapors would lose energy when you decrease temperature, and they would turn into liquid. Is this clear? This one, that if you decrease temperature, condensation would be a much faster, right? Is that clear?
Yes, sir.
So condensation is what type of reaction? It's an exothermic reaction, right? When condensation happens, molecules lose energy, so that means it's an exothermic reaction. Okay, so we can make a general rule, which is that whenever you increase temperature, endothermic is favored. Whenever you decrease temperature, the exothermic reaction is favored. Okay, if you increase temperature, evaporation would be faster, which takes in energy. Okay, which takes in energy, so endothermic is a lot faster. Okay, clear?
Yes, sir.
अच्छा फिर वो जल्दी से ना the second point, which is if we increase pressure, so if we increase if we increase pressure, increasing pressure means that you're decreasing volume. ठीक है, increasing pressure means I'm compressing it. ठीक है, I'm compressing the container. So whenever you increase pressure, you basically decrease the volume. So if you're decreasing the volume, okay, well, let's say it's kind of volume, we can pick the container and इसका volume को decrease करें एक second. ठीक है. अच्छा, so I'm going to decrease the volume. ठीक है. So if I decrease the volume and let's say ऊपर से ना pressure is being applied and the container is getting squeezed, so what happens is कि there is less room for water vapors to form. Let's say यहाँ तक हो गया. So when I increase pressure, so the volume all of a sudden decreases, right? So if the volume decreases, what's going to happen is less gas is going to be produced. ठीक है, so whenever you increase pressure, the volume starts to decrease. There's less room for gas, so less water vapor is going to be formed. ठीक है, naturally less water vapor would be formed. Vice versa, if I decrease pressure का मतलब है कि what I'm going to do is I'm going to take this and decrease pressure means I'm going to take this. Decreasing pressure means I'm increasing the volume. So if I increase the volume, now all of a sudden you have a lot more volume, and if you have a lot more volume, a lot more evaporation would happen, and a lot more water vapors are going to be formed. ठीक है? So we can make this general rule that is that if you decrease pressure, so what you're doing is you're increasing the volume. And the side that has more gas moles का मतलब more gas is going to get produced. ठीक है, तो ये आपके ना दो रूल्स हो गए. ठीक है, that's number one. ठीक है, that's for pressure. ठीक है. And remember, pressure only is applicable to gases. I mean, the reaction should have gases, only then pressure would make sense. ठीक है, ये दोनों क्लियर है?
Yes, sir.
अच्छा, finally third rule is that if you increase or decrease the concentration of something, the equilibrium is going to do the opposite. ठीक है? For example, if I go in and I remove the water vapors, right? So what will the equilibrium do? Uh, there'll just be more evaporation and more water vapors are going to get formed. That's it. ठीक है? There's going to be more. So it's going to do the opposite. If I try to remove one thing, it will try to just reproduce it. If I try to add more water vapors, like if I add extra water vapors, what will it do? If I add extra water vapors, the rate of condensation will be a lot faster. So the amount of water vapors are going to decrease. ठीक है? तो अगर आप, if you remove them, all of them, it will just form them back again. As long as you've got water, evaporation will happen and more water vapors are going to get formed. Okay. So the last rule is that it's just going to do the opposite. So last rule is, okay, if you decrease or increase the concentration, okay, remember this is applicable to concentration only. Concentration of a reactant or product so the equilibrium does the exact opposite. Okay. So that's your final rule. Okay. And remember, this rule is only applicable to concentration. Concentration is something that is applied to solutions or to gases. ठीक है? So it's only for solutions and gases. ठीक है? Remember, liquids have constant concentration. You can't change the concentration of a liquid or a solid. Concentration होती क्या है? That's the number of particles per unit volume, right? So it's the number of particles per unit volume. If for a solid and for a liquid, the number of particles, because they're tightly packed, I mean, they're almost touching each other. So concentration is more about spacing of the particles, right? मतलब concentration का मतलब ये होता है, concentration is how close together particles are. ठीक है? So for example, if these particles are like far away and then you have another solution or you have a gas and the particles are like really close together, so this means that the concentration is low. They're not very concentrated. This means that they are very concentrated. So this only happens in solutions and gases where the spacing of the particles can change. Liquid के अंदर अगर particles होंगे ना, if it's a solution, the particles could be very far away or the particles could be very crowded together. ठीक है? And that's also applicable to gases. In gases, the spacing changes. Gas particles could be close together. Maybe at high pressure, they're forced together close to each other. Or maybe they are at low pressure, they're like very far away. Okay, so solids के अंदर concentration does not make sense because solids के अंदर the particles are always tightly packed. So if they're always tightly packed, so the spacing doesn't change. So they're always having the same concentration. Same with liquids. Liquids are like solids. The particles are kind of tightly packed, except that they can move around. So liquid के अंदर भी spacing does not change. ठीक है? So just remember that the last rule is only for concentration and it's only for solutions and for gases. ठीक है? Clear है ये बात भी?
Yes.
Actually, that's all the Shatler principle. We'll just do some AS past paper questions related to that. So 1 second. अच्छा इधर होगा ली शैटलर प्रिंसिपल. ठीक है? So remember 3 rules. ठीक है? So first one, You got these two reactions. He's saying that NOCl is added to a pool. तो उसके water के अंदर add किया and you get this reversible reaction. ठीक है? The OCl ions they break down and they produce OH ions and HOCl, but it's a reversible reaction. And then he says that in bright sunshine, the OCl ions they also react with UV light and they produce these two molecules, one ion and one O2 gas molecule. This is not a reversible reaction. So which method would maintain the highest concentration of HOCl? So basically, he's looking for a higher concentration of HOCl. You want more of HOCl. The first one, okay, if you acidify the pool water, what's going to happen? If I add acid to it, what will happen to this reaction? क्या होगा, anyone?
Sir, the acid in this case, is it the HOCl, sir?
We don't know. He's just saying that if you add acid to it.
Okay.
What does acidify the pool mean? Okay, what ion is being added?
H plus, sir. Hydrogen ion, sir.
ठीक है, एक सेकेंड. अच्छा, so you're adding H plus ions, right? So you're adding H plus ions. What will adding H plus ions do to this reaction?
Is it neutralized?
Remember the H plus ions, they tend to neutralize OH ions, right? So यहाँ पे ना you got OH ions, right? So if you add a lot of H plus ions, the OH ion would get neutralized and the concentration would decrease. Okay? So the OH ion concentration would decrease if you add too much H plus ions. So if the OH ion concentration is decreasing, right? Where would the equilibrium shift? क्या rule क्या था कि if you decrease the concentration of a particular substance, equilibrium will try to make more of it. It's going to do the reverse. So it's going to favor that reaction that produces more OH ions. ठीक है? ये clear है कि adding H plus ions will eventually neutralize the OH ions over here. And if the OH ion concentration decreases, the rule is that the equilibrium will try to do the opposite and it will try to produce more OH ions. ठीक है? Clear है ये बात?
Yes, sir.
So it will favor the forward reaction, right? And if it favors the forward reaction, तो क्या होगा? What will happen to HOCl? There's more HOCl gets produced. So that means A is correct. Because he wanted more HOCl. So that means the forward reaction is going to be favored and more HOCl will be produced. बाकी क्यों गलत है? बाकी जल्दी से देख लेते हैं. If you add a solution of chloride ions. Now chloride is Cl minus 1. Cl minus 1 has nothing to do over here. There is no Cl minus 1. Cl minus 1 is over here. Lekin this reaction is pointless because even if you add more Cl ions, the reaction is not reversible. So that means even if you add more Cl ions, the equilibrium is not going to shift. It's not going to move backward or forward. Okay, so nothing would happen. Okay, in this case. Second wale ke case mein. Third one is if you add a solution of hydroxide ions. So agar aap na, if you increase the quantity of hydroxide ions, if you add more OH ions, right? So if you add more OH ions, the equilibrium will try to do the opposite. It's going to try and decrease them. So how is it going to decrease them? It's going to favor the backward reaction. It will try to convert the OH ions into something else. So that is not right. We want the forward reaction to happen. We don't want the backward reaction to happen. So ये जो hydroxide ions वाली बात है ना, it's you're not supposed to increase them. ठीक है? As the last one, bubble air through water. So air is oxygen. So oxygen, if you bubble it, doesn't really matter because it's not a reversible reaction. ठीक है? तो clear है? पहला question clear है? Is this clear?
Yes, sir.
Sound clear है?
Yes.
Yes, sir.
That's the next one. Which statements are correct? Increasing the pressure increases the equilibrium yield of SO3. The first one, increasing pressure, which side is favored? If you have something at a higher pressure, so rule kya tha? The less gas moles side is favored, right? Increasing pressure means you're compressing it. That means you're decreasing the volume. So less gas would be produced. So kaun si side hai? Which side has less gas? If products are formed, so how many moles of gas? 2 moles? Vice versa, if backward reaction is favored, how many moles of gas is produced? That's 3 moles, right? एक ये, दो ये, ठीक है, that's 3 moles. So left side पे you got 3 moles of gas, right side you got 2 moles of gas. So less gas mole side is forward, right? So that means the forward reaction is going to be favored and there's going to be more SO3 produced, ठीक है? So that means first one correct है, ठीक है? Achha, baki KP we haven't yet started. We'll just quickly do that in the next classes. Catalyst, what does catalyst do to the equilibrium position? ये मैं add भी कर लेता हूँ. What does a catalyst do? It does absolutely nothing. ठीक है, remember this. What a catalyst does is that it speeds up both forward and backward reaction. But if both forward and backward reactions are equally speeded up, the equilibrium position is not going to be changed. So your equilibrium position is kind of unchanged because overall nothing will happen. Both forward and backward reactions are going to get speeded up equally. So presence of catalyst increases the yield. No, it doesn't. It just makes the reaction faster. But it also makes the backward reaction faster. So overall, no effect would happen to the amount of SO3 produced. अच्छा इसका मुझे बता दे कोई कि which statement about reversible reactions are correct? An increase in a concentration of reactant always increases the concentration of the product. Is that true? Agar if I increase the concentration of the reactant, right? What would the equilibrium do? It will try to do the opposite. It will try to decrease the concentration of the reactant. How will it decrease the concentration of the reactant? By favoring the products. It's going to convert some of the reactants to the two products, right? So whenever I increase the concentration of the reactant, the equilibrium will automatically try to decrease it and it will favor the forward reaction, right? So more products are going to be produced. So that means the concentration of the product is going to increase. Okay? It's definitely going to increase. I say an increase in temperature always increases the rate at which the equilibrium is established. इसमें याद रखना one thing कि whenever you talk about equilibrium, make sure you don't confuse it with rate. ये मैं यहाँ पे add भी कर लूँ कि always remember that अच्छा equilibrium and rate are separate. ठीक है, they are completely separate. ठीक है, so equilibrium should not be confused with rate. Rate is about speed of reaction. Equilibrium is about the relative speed of forward and backward reaction. Relative means in comparison. Rate जो है ना, that's the actual speed. And when you talk about rate, the rate of a reaction increases with when you do 5 things. So it always increases. Number one is temperature. Two is pressure. That's for gases. Remember, pressure जो है ना, that only works with gases. Gases are the only thing that are compressible. So 3 is concentration. And remember, the term concentration is only applicable to solutions and gases. Number 4 is catalyst. And your number 5 is surface area. So rate is actual speed. When you make a comment about equilibrium, that's the relative speed. When I say that the forward reaction is faster, that doesn't mean it's faster in absolute terms. It just means that it's faster compared to the backward reaction. So when I say that one of the reaction is faster compared to the other one, that is just a relative comparison. Okay? Equilibrium is a relative comparison. It just means maybe both reactions are slowing down, but one of them is still going to be faster compared to the other one. Or maybe both of the reactions are speeding up, but one of them is going to be faster compared to the other one. Okay? So ये इसमें confused ना होना. When you make a comment about equilibrium position, it's not about their absolute speed, it's about their relative speed. हो सकता है कि both of them are slowing down, but one of them is still faster than the other one. Or maybe both of them are speeding up, but one of them is faster compared to the other one. And when they talk about rate is the actual speed. They're talking about the actual speed. So for example, इसी को कर लेते हैं, if you increase the temperature, he's talking about rate over here. So when he's talking about the rate of the reaction, whenever you increase temperature, the rate always increases. Okay? So this statement is true because it's not a statement about equilibrium. It's a statement about the rate of reaction. Okay? ये clear है? ये बात clear है?
Yes, sir.
Yes, sir.
Or an increase in temperature always increases the concentration of the product. That's not true. Because whenever you increase temperature, which reaction is favored? It's always the endothermic favor होता है. अब मसला ये कि the endothermic could be forward, it could be backward. It varies from reactions to reactions. Some reactions are endothermic, some are exothermic. So we can't really be sure that the products are increasing or not because we don't know whether it's an endothermic reaction in the forward direction or is it an exothermic reaction. So it varies a lot. Okay? So the third statement is not always true. Okay? Is it clear?
Yes, sir.
बस इसके ऊपर मैं एक कमेंट कर लूं फिर से कि अच्छा, let's say I increase pressure. तो रूल क्या है? Less gas pull side is favored, right? Which is in this case forward, right? So the forward reaction is going to get favored. So लेकिन remember कि equilibrium comment is about the relative speed. When I say the forward reaction is favored, I just mean कि the forward is faster compared to the backward. That's it. अच्छा, अगर question rate पे होता, ठीक है, if he had asked about rate, whenever you increase pressure, what is the rule? Whenever you increase pressure, whether it's the forward or backward reaction, both would speed up. So if the question was about the rate of reaction, so that means both forward both of them would speed up. So ये थोड़ा सा difference याद रखना whether is the comment about equilibrium or is he talking about rate of reaction? The equilibrium is the relative speed or rate के अंदर when he's talking about rate, then he's actually talking about the actual speed. So if he talks about increasing pressure, no matter whether it's the forward or backward reaction, they're all going to speed up. But when he's talking about equilibrium, then the forward is the one that's going to be more speeding up. It's going to be more favored. ठीक है? ये clear है difference इन दोनों में? Is this clear?
Yes, sir.
Yes, sir.
ठीक है. चलो ठीक है. Let's continue tomorrow. ठीक है. We'll just cover the AS stuff, or फिर we'll start with the. After that, we'll start with the A2. ठीक है. इसके थोड़े से we'll do more questions related to Lee Chatelier principle, and then we'll do KC and KP. ठीक है. चलें. Okay, everyone.
Okay, sir.
ठीक है. अल्लाह हाफिज.